Okay, what we want to do here is look at some of the Linux tools. Some of them are a little bit different than the Windows tools. The commands are a little bit different. Some of the things that you see are a little different. One of the things specifically, the Ifconfig command will show you your IP configuration, but will not show you the default gateway. So we'll look at the route command to see the default gateway. This is a Linux machine. We'll take a look at it here for a few minutes. When you take your Linux classes, please pay attention, because when you get to security, you're going to find that most security tools run on a Linux platform. A lot more configurable. The open source, the tools get developed, the hacker tools and the security tools. A lot of things that are hacker tools are really can be hacker tools, can be network administrator tools, depending on how you're using them. We talk about port scans when we're looking for open ports to try to attack something. Yes, a hacker will use that. Yes, a network administrator should use that to see if there are any odd ports open, like maybe somebody has attacked you and opened a port that shouldn't be there. So you should scan, and scan your own home network occasionally. If you want to find the IP address, the public IP address of your router at home, I think whatsmyip.com will tell you what your IP address is, your public IP address. So then you could come here, for instance, and scan your network to see if there's anything odd going on your network at home. So those things are available. Those are kinds of things that you get used to using the tools by doing things that are useful to yourself, to you. So we'll look at a couple of these things. The first one, the trace should work. Trace is going to be the same thing. There's a cooler trace that we're going to look at here in just a second called My Trace Route. But the first one we did Ifconfig, IF interface. I'm going to click in here. Ifconfig. When we look at that, it gives us ETH1, the Ethernet, ETH1 and LO, which is the loopback. Tells us what our IP address is, what the broadcast address is for that network. That's kind of handy, isn't it? And that's the broadcast address based on the IP address that's in here. This one's 1060.64.188. The broadcast 1060.67.255. The mask 255.255.252. So this is a super netted network. Kind of cool there, huh? We have a IPv6 address. The NICs are IPv6 capable. They determine their own, at this point, on our network at least, determine their own IPv6 address. Transmit packets and receive packets are up here, collisions. And in the world of switches, we really shouldn't be seeing collisions. But if you have collisions in there, a little bit more information in the Linux than was in the Windows. True? If you didn't want to see all of this, or if it gets too long, you can do an Ifconfig. You can specify the interface. We could do an Ifconfig ETH1 if we wanted to do that. So a little bit different, and on this test, they ask things like, what's the default gateway? You notice the default gateway is not here. The default gateway does not show up here. All the other information does, including the collisions. In order to get the default gateway, and let's look at that one quickly while we're here, we would use the route command. The route command in Linux can be used to add routes. Linux, by the way, unlike Windows, by default, by its existence, supports routing. So if we put two NICs in a Linux machine, we got a router. And the route command can be used to put routes into that machine. And also, in the route that it puts in on this one is the default gateway. We have destination 1060.64.0.255.255.252, and it says the interface. What interface is it going to go out? It's going to go out ETH1, which is the only one we have, but that's going to be the local network. So that's one. We talked about ARP a little earlier. ARP protocol works here just like all the other ones do. It would ARP for the MAC address on that network, for the MAC address of the IP address that it was trying to get to. When we get on down this thing, a number of different link local, and link local, when we talk about those, link local are IPv6 addresses. Those would be the ones, if there were such a thing as private IP addresses in IPv6, those would be private IP addresses, but they're linked local addresses. System generates its own right now. And then we have the loopback address. Back to the loopback address, more review, 127.0.0.1, where we take that entire Class A range and use one address. 127.0.0.1 is the only address that we use in here. Down here at the bottom where we're finally trying to go to the default, and this is the default gateway 1060.64.1. So the route command is the one that tells us what the gateway is. The Ifconfig command in Linux, ipconfig command in Windows, ipconfig/all, the things that we reviewed, and the ifconfig here tell us, and the ifconfig up here obviously tell us what the addresses are, the mask, those sorts of things. But it doesn't tell us the default gateway. So if you are asked a question, how do you find the default gateway, and you don't have an ipconfig command or an ipconfig all command, the route command should tell you that. So we can find those things there. One of the other ones that we have in Linux that you can get a download for Windows is the ARP ping. And remember, ARP is the protocol, the tool that tells us what the MAC address is. ARP ping, and since I've played here a little bit, but not lately, huh? ARP ping. There's something on this network. Oh yeah, dash. Got to tell it where it's going out. ETH1, right? I know. If we actually read the help screen, which I didn't do very well, the dash S is the source address. The dash capital I here is the device. And I was trying to put the source address is ETH1. Well, that won't work. Dash I will. If I do this thing, and let's do the dash I with google.com, after I get back into the machine, it gives me the IP address and the MAC address. Which MAC address do you think this is? Since I'm going to Google. Okay, this is a 50-50-90 question. Which MAC address do you think this is? Remote what MAC address? Remote MAC address of what? Based on what we said earlier, what's the MAC address? What does it, if it's on a different network, what does it ARP for? Which MAC address? Server, router's MAC address, exactly. So you think that this is Google's MAC address, 72.14.204.105? You think that's the MAC address that goes with that IP address? I don't. Why? Could we do that? We kind of could with NBTstat if the server at the other end cooperated and told us. So you can, there is a switch in NBTstat that a server running NetBIOS would do that. But if we're running Linux on this one, there's not going to be any NetBIOS service. If Google's running, which they probably are, they're probably not running a Windows machine with NetBIOS. It's going to tell you all the stuff that you want to know. So this thing is telling us what the MAC address is of the default gateway. And let's look at that real quick. We know that based on the route command that the default gateway was 1060.64.1, right? If we'll go back to that. Let's go back and let's see if I lied to you about that one. That was the route command, right? The default gateway 1060.64.1. So now then, let's use that ARP ping, and let's go to, and notice that the address up here is 001319FF9C42. I usually try to remember things like the last two digits because they change a lot. Is it going to be that? And that's the unique portion. So the last 6 hexadecimal numbers should be unique. The first 6 hexadecimal numbers are going to be the manufacturer. So those can have duplication. This thing split into the MAC address split up into over here, the 001319 would be the manufacturer's code. The FF9C42 would be the unique serial number that goes with that code. It's kind of like phone numbers. Area code or exchange, and then we have unique 4-digit numbers after that. These are just similar concept, different numbers. So let's look at this at 10.60.64.1. Golly, it's the same one, 001319FF9C42. And that's only going as far as the interface on the router. So we could make the conclusion, come to the conclusion, I think, that the MAC address that it found with the ARP ping is the MAC address of the default gateway. If we were looking for MAC addresses of local machines, we could ping local IP addresses and it would return the MAC address of those machines when we went through those things. So, and ARP we've already looked at. ARP's going to be the same thing here. NS lookup's going to be the same thing here. A different command that Linux uses is the dig command, which is essentially, not essentially, it's the same as the NS lookup. Dig, what I got here was the root servers. And the root servers are those servers, and we're going to look at DNS in a minute. The root servers are the ones that starts out at, like .com, .edu, .mil, where the process starts. So these are the listings of the name servers that tell us where to get started in order to find the IP address that goes along with the name. So dig, a way to do name lookups. A Linux specific, it's not a Windows command. NS lookup was the command we used in Windows. NS lookup is also available in Linux, so we can use it in either of the operating systems. MTR is my trace route. See if I can get this one right. Does the tracing, it did a lot faster than we did in Windows, didn't it? Did it take Windows an awful lot longer to get there? What this does is give us a continuous update of what's going on along that route. How long is it taking to get the replies back? And over here we have a loss, and we have a 0% loss, and that's what we want to see. If we start having losses, and again, remember that along this path, if we have a failure at any place along the trace, that's the router that has the issue. So MTR, my trace route, handy tool, gives you a summary, an up-to-date summary as it goes along, as we look at what the statistics are on how long it's going to do, what's the times to get there and the times to get back. The route command we've already looked at. Netstat. Netstat, again, is a command that should work in Linux just like it worked in Windows. And these are connected. Remember, we have the listening ports and we have the connected ports. The listening ports are listening for something to connect to it when you look at the netstat command. Listening ports that we have a service running. If we had a web server running, that's always the easy one to talk about, and we do netstat. Netstat would be listening on port 80 because that's what we connect to for the HTTP protocol. If we had a connection, if we were actually connected, we would have our ephemeral port, our random port in the local, and then in the remote we would have what we're actually connected to. So netstat works on both of them. Linux has some unique, I guess, some pretty neat tools that go along that you can use on it. Windows, if you look hard enough, you can probably find things that you can download and install on a Windows machine that will do a lot of these, not all of these, but a lot of these. I think my trace route, which to me is one of the kind of neater ones because it gives you a continuous update, does have a Windows download that does those. But those are the tools that we've talked about, the troubleshooting tools that we use at, again, how far have we gotten? We're still at layer 3. Have we done anything else? Keep in mind, Telnet is a tool you can use to actually connect to a service to prove that you have connectivity at layer 7. Layer 3 generally is going to help us out a lot. The reason we only go that far, we're layer 3, and we could actually go on up to layer 4, I guess. That's as far as routers go. So when you're routing, when you're sending information from one location to the other, that's as far as they go. Everything else is part of the computer itself, part of the server itself. It's part of the service. So to get stuff from one location to the other, those are the things that we're talking about. Okay, I'm going to stop this so I can resize it.